Okay. Investigation 1 here. What we're going to do is just do a little investigation, see if we can come up with a shortcut that will save us time when we want to figure out if two triangles are similar. So let's get into the PowerPoint here, and I'll go to the slide. Okay. And it says, in this investigation, we will check the first similarity shortcut. If the two angles in two triangles are congruent, is that enough to say the triangles are congruent? Okay? And so what you're going to end up making is drawing two triangles, ABC, another triangle, DEF, with these angle measurements. So when you do this investigation, you are going to need a ruler. Probably with centimeters is easier, but you can do it with inches. And you're going to need a protractor so you can draw the angles. So let's get on with the investigation. Okay, so first it says draw a triangle ABC where a measurement of angle A and measurement of angle B are equal sensible values of your choosing. And I chose 50 degrees and 40 degrees. Okay, and so let me get my pointer here. Okay, so we have down here a 50-degree angle and a 40-degree angle. Okay, so now what I'm going to do is I'm going to make another triangle that has a length different for AB, but still has the angle 50 degrees and 40 degrees on the bottom of it. Okay, and that's what I've done here. So step 2 is draw triangle DEF, where, if you look here, I'm going to change the pointer again. So you see here, A and D are the same, they're both 50 degrees, and 40 degrees, or angle B, is the same as, so B and E are also the same. Okay, so, but the key is we want this to not be the same length as this. So AB is not the same as DE. That's the key. Otherwise you're just drawing congruent triangles. Okay, and so we go to the next step. Are your triangles similar? We know those are the only two things for sure. So we don't have any shortcuts at this point. So we have to ask ourselves, what could we do to show that the triangles are similar? Well, remember for triangle similarity, there are two conditions. The first condition, so I'll do it up here. The first condition is that corresponding angles are congruent. Okay? The second condition is that corresponding, or let's just say sides, are proportional. Okay? That's the two things we have to check to see. That's the only way we know how to say two shapes are similar. Okay? Now for triangles, we're trying to come up with some shortcuts because we deal with lots of triangles. So first of all, how big is this angle? Well, it's 180 minus 50 minus 40, and that's 90 degrees. So how big is this angle? Well, that's 180 minus 50, which is 130, minus 40, which is 90 degrees. So we see that this angle is the same as this angle, and we now have corresponding angles being congruent. So we've met the first condition. Now that doesn't mean that they're similar yet. We haven't proved anything, but we met the first condition. So let me clean this up, and we'll come back and we'll talk about the sides. We have to do the sides are in proportion. So if I go here, I'm going to erase it all. So we already proved the first step. the first step up here was there we go. The first step was the corresponding angles are congruent. That we worked. Now we're going to check this one, that the sides are proportional. So the sides are proportional. Okay, so what we need to do is get these side lengths. So you're going to need to get a ruler out. Your numbers may be a little bit different than mine, or maybe greatly different depending on your screen resolution. But I'm going to have to measure AC, BC, AB, and compare AC to DF, CB to FE, and AB to DE. So I'm going to do that right now. I'm going to write the numbers in as I do it. So you're going to have to listen to me say it, and then I'm going to write them in so you'll have a better idea. So with my ruler, I'm measuring AC right now, and it says on my screen it's about 5.2 centimeters. I recommend you use centimeters. It's easier to do all the decimals and stuff, but you can do it in inches. 5.2 centimeters. Okay? So now I'm going to measure BC. I got 6 centimeters exactly. So this is 6 centimeters. Since this is 90, I expect this to be bigger than 6 centimeters. So we'll check that right now. And I got 8.2 centimeters with my ruler here. 8.2 centimeters. Okay? So now we're going to do the same thing over here. We're going to measure all these. So DF looks like about 7.2 centimeters. Okay, so I got the pen working again, 7.2 centimeters. Okay, and I'm going to do FE. FE is 30, that's not 30 centimeters. I got about 8.6 centimeters. 8.6 centimeters. And then the last one, DE, is, looks like about 11.2, maybe 11.3. I'll say 11.2 since we've got all the decimals being 0.2. Okay. Now, so now we have to check, is this side corresponds to this side. So let's make a fraction. The small one on top, 5.2 over 7.2, that should be the same as this side and this side as a fraction. So 6 over 8 is the same as 1, 2, 3 over 1, 2, 3. So I'm going to do 8.2 over 11.2. Now you could cross multiply and check if they're close to the same, and then cross multiply and then do that. But these are just to reduce these. Get a calculator and reduce these and see what decimal they equal, and they should be very close to the same. Okay? So that's what we're trying to check. If they're proportional, then if we do that, then we'll say the sides are proportional. So I'm getting my calculator out here. Okay, so 5.2 divided by 7.2 is about 0.72 repeating. So if I write this down over here, it's about 0.72 repeating here. Okay, we know already this is 0.75. And we just have to check this one here. So I'll check this one. 8.2 divided by 11.2 is 0.7321. And then more decimals, but that's, and what we're seeing is these aren't perfectly similar, but they're very close to similar. So I'm going to say up here, if I were to do this, okay, it's approximately similar, or approximately proportional. So I'm going to just put a check mark there, and I've met the criteria. I've got congruent angles, and I've got proportional sides. So these are similar. So that should come up with the next shortcut. If you have triangles, and you know two corresponding sets of sides are, two corresponding sets of angles are congruent, then that's enough information to say that the triangles are similar. And you'll see that on the next slide. I hope this made sense.